Chapter 6: Media Type Selection and Design. A good contract lets friends stay friends. It is common to hear developers explain how REST-based systems are better than OW. To natives for building web APIs because they are simpler. The lack of contracts, such as WSDL Web Service Description Language, is often cited as one of the reasons for the simplicity. However, when building distributed systems, you cannot avoid coming to some kind of prearranged agreement between components. Without some form of shared node edge, those components cannot interact in a meaningful way. This chapter is about the types of contracts used in web architecture, the process of selecting the best contracts to meet our needs, and identifying where it's necessary to create new contracts. Self-description. One of the key concepts around designing contracts is self-description. Ideally, a message should contain all the information the recipient needs to understand the intent of the sender, or at least provide references to where the necessary information can be found. Imagine you receive a letter in the mail that has the numbers 43.0338471.07338 written on it. That letter provides you with all the data that you need to achieve a very specific goal, but you are missing all of the context required to do anything useful with it. If I were to tell you that the pair of numbers were latitude and longitude coordinates, then you would have some understanding of their meaning. Obviously, I am assuming that you either already understand that coordinate system or are capable of searching for information on how to use it. Self-descriptive does not mean that the message needs to actually include a description of the longitude/latitude system. It simply needs to reference it in some way. Knowing that the information included in the letter is coordinates is only half the story. What are you supposed to do with those coordinates? More context is needed for you to know what you should do with that information. If you see that the letter's return address is Great Places to Drink, P.O. Box 2000 Nevada, you have a hint that maybe the coordinates are the location of the recommended pub. Types of contracts in the web world. Media types are used to convey what a resource represents, and a link relation suggests why you should care about that resource. These are the contracts that we can use when building evolvable systems. These pieces of the architecture represent the shared knowledge. These are the parts of the system that we have to be careful to design well, because when they change, they could break components that depend on them. Media types. Media types are platform-independent types designed for communication between distributed systems. Media types carry information. How that information is represented is defined in a written specification. Unfortunately, the potential for media types is woefully underused in the world of web APIs. The vast majority of web APIs limit their support to application/XML and application/JSON. These two media types have very little capability to carry meaningful semantics and often lead people to use out-of-band knowledge to interpret them. Out-of-band knowledge is the opposite of self-descriptive. To return to our letter example, if the Great Places to Drink company were to tell you ahead of your receiving the letter that the numbers written on your letter would be geographic coordinates, that would be considered out-of-band knowledge. The information needed to interpret the data is communicated in some way separate from the message itself. In the case of generic types like application/XML and application/JSON, it requires us to communicate the semantics of the message in some other way. Depending on how we do that, it can make evolving a system much more difficult because it requires communicating changes to the system in that out-of-band manner. When out-of-band knowledge is used, clients assume that the server will send certain content and therefore they are unable to automatically adapt if a server returns something different. The result is that server behavior becomes knocked down by the existence of clients. This can become a major inhibitor of change. Primitive formats. This section includes examples that show how the same set of data is communicated through different media types. The media type application/octet stream, shown in example 6:1, is about as basic a media type as you can get. T is simply a stream of bytes. User agents who receive this media type usually cannot do anything with the payload other than allow the user to save the bytes in a file. T. Here are no application semantics defined at all. Example 6:1. A stream of bytes get /some mystery resource 200 OK content type application/octet stream content length 20. 003B00000001000101100080016D00003FFFF. In example 6:2, media type text/plain tells us that the content can be safely rendered directly to an end user, who will be able to read the data in its current form. The example body does not provide any hints as to what the data is for. However, there is nothing to stop a server from including a paragraph of prose in the body with an explanation of the information. Example 6:2. Humor. Unreadable get /some mystery resource 200 OK content type text/plain content length 29. 59-013-117-38,365-3655535. Who knows my business? In the last 50 years of computing, we have played distributed ping-pong with the semantics of our business applications. In the days of the mainframe, the server knew everything about your data and the client was a terminal that knew nothing more than how to display characters and detect key presses. In the 80s and early 90s, with the rise of personal computers and local area networks, the clients became king. Data was still stored on a file server, but as far as the server was concerned it was just dealing with files, rows, columns, and indexes. All the intelligence was on the client. Toward the end of the 90s, client/server databases gained popularity due to the fact that PC-based networked applications were being stretched to the limits of their extremely chatty architecture, and client/server databases promised huge scalability improvements. Client/server databases had limited success in driving rich client applications, not because of any technical problem but because many developers had insufficient training and tried to apply the techniques used for ISM indexed sequential access method databases on client/server databases. This problem was exacerbated by vendors pushing client/server databases as a drop-in replacement to achieve scalability. The new millennium saw the rise of the web application. Web applications worked well because they moved the application workflow and business logic onto a server that lives close to the data. This addressed the problem of chatty PC-based networks and avoided some of the concurrency problems that were tricky to handle using client/server data bases. In recent years, JavaScript has gone from augmenting HTML-based web experiences to creating and controlling web experiences. We are seeing a trend of moving application workflow and logic back onto the client but within the runtime environment of a web browser. If we are to move logic back to the client, it is important we understand why this has failed in the past, so as to avoid repeating the mistakes of our predecessors. Hypermedia-enabled media types are a very important part of this critical architectural decision because they are able to carry both workflow and application semantics across the wire and allow more intelligent distribution of workload between client and server. In example 6.2.3, the media type text/CSV provides some structure to the information being returned. The data model is defined as a set of comma-separated values that are then broken down into lines of usually structurally similar data. We still have no idea what the data is, but we could at least format the data for presentation to a user, assuming the user knows what she is looking at. Example 6.2.3. S. Imply structured data get /some mystery resource 200 OK content type text /CSV content length 29. 59.013.117.38,365 3,65535. Popular formats consider example 6.2.4. Example 6.2.4. M. Arcup get /some mystery resource 200 OK content type application /XML content length 29. In this particular case, returning the content as XML did not add any more semantics than the text/CSV format did. We still just have 5 pairs of digits, but it does provide a place to name the pieces of data. However, the meaning of those names is not being defined in the specification for application /XML. So any client that tries to assign meaning to those names is depending on out-of-band knowledge and therefore introducing hidden coupling. In this chapter, we will discuss other ways to layer semantics on top of generic media types without creating hidden coupling. For more complex scenarios, application /XML can be useful to represent hierarchies of data and allow blocks of text to be marked up with additional data. However, we still have the problem that application /XML provides limited ways to assign semantics. As far as communicating semantics, application /SEM shown in example 6.2.5 has even less capability than application /XML. The advantage of consuming SEM within a web browser environment is that we can download JavaScript code that can apply semantics to the document. This allows clients and servers to evolve simultaneously, but it has the disadvantage of limiting clients to those that can support a JavaScript runtime. This also impacts the ability for intermediary components to interact with the message, thereby limiting the benefits of the HTTP-layered architecture. Example 6.2.5. Object serialization get /some mystery resource 200 OK content type application /some content length 29. Objects. Property 1 equals 59. Property 2 equals 0. Property 1 equals 13. Property 2 equals 1. Property 1 equals 17. Property 2 equals 30. Property 1 equals 8. Property 2 equals 365. Property 1 equals 3. Property 2 equals 65535. If generic media types are at one end of a continuum of media types, then the next example is at the opposite end. In this case, we have defined a new media type that is specific to our particular application and has exactly the semantics that the server understands. To deliver this content, we need to write a specification for the media type, make it publicly available on the internet, and preferably register the media type with IANA, so that it can easily be found by a developer who wishes to understand the meaning of the representation he just received. New formats. Now let's consider example 6-6. Example 6-6. S. This specific format get / some mystery resource 200 OK content type application / vnd.acme.cache stats xml content length. Cache stats. This media type finally conveys that the data we have been dealing with is the series of data points for a graph that shows the frequency distribution of the length of the message cache control header of requests on the internet. T. His media type provides all the information a client needs for rendering a graph of this information. H. However, the applicability of this media type is fairly specific. How often is someone going to write an application that needs to render a graph of caching statistics? T. The idea of writing a specification and submitting that specification to IANA for registration seems like overkill. T. The vast majority of today's web APIs create these narrowly focused payloads but just don't bother with the specification and registration part of the process. There are alternatives, though, that provide all the information needed by the client, and yet can be applicable to far more scenarios. Consider the scenario in example 6-7. Example 6-7. Domain-specific format get / some mystery resource 200 OK content type application / data series xml content length. Series axisTip equals range. YaxisTip equals %. Title equals % of requests with their max age value in days. In this case, we have created a media type whose purpose is to deliver a series of data points that can be used to plot a graph. T could be a line graph, a pie chart, a histogram, or even just a table of data. The client can understand the semantics of the data points from the perspective of drawing a graph. T doesn't know what the graph is about. That is left for the human consumer to appreciate. H. However, the additional semantics allow the client to do things like overlay graphs, switch axes, and zoom to portions of the graph. The reusability of this media type is vastly higher than that of the application / vnd.acme.cache stats xml. NY application scenario where there is some data to be graphed could make use of this media type. T. The time and effort put into writing a specification to completely describe this format could quickly pay off. It is my opinion that this kind of domain-specific, but not service-specific, media type is the optimal balance of semantics that media types should convey. T. Here are a few examples of this sort of media type that have proven quite successful. HTML was conceived as a way of communicating hyperlinked textual documents. Atom was designed as a way to enable syndication of web-based blogs. ActivityStream is a way of representing streams of events. JSON Home is designed to enable discovery of resources made available in an API. JSON Problem is a media type designed to provide details on errors returned from an API. All of these media type examples have several things in common. They have semantics that are intended to solve a specific problem, but they are not specific to any particular application. Every API needs to return error information. Most applications have areas where there is some stream of events. These media types are defined in a completely platform and language agnostic way, which means that they can be used by every developer in any type of application. There remain many opportunities for defining new media types that would be reusable across many applications. Hypermedia types. Hypermedia types are a class of media types that are usually text-based and contain links to other resources. By providing links within representations, user agents are able to navigate from one representation to another based on their understanding of the meaning of the link. Hypermedia types play a huge role in decoupling clients from servers. Through hypermedia, clients no longer need to have pre-existing knowledge of resources exposed on the web. Resources can be discovered at